just published a new blog post where I show the findings with regards to the use of a 50-watt LED in our 7.6 centimeter wide heatsink, with the use also of a 20 CFM fan. These two photos show the experimental array. Below this heatsink is the LED. It can't be seen in the photos. Above it is the heatsink, and above the heatsink, with the center of the fan, is the fan, where the center of the fan is centered to the center also of the LED. These are two thermal images taken for two different lengths. One is 20 centimeters and the other one is 9.2 centimeters. These two values show the temperature, the recorded temperature from the thermal camera. They shouldn't be taken as precise values. More like they should be taken more like behavioral change. So it is natural to see that there is an increase in the temperature with a decrease in the heatsink length, given that the fan is working in both instances. The LED is a 50-watt LED, as I mentioned, and this 52.4 watts is the exact, is a more precise measurement of the electric power. Finally, the table 1 shows the important data, and that is that in both cases, the temperature measured directly over the PCV is less than 85 degrees centigrade, which is recommended by CREE. And one case is 65.1 and the other 57.2. The heatsink temperature is about around 15 degrees less, and in one case the thermal resistance is estimated to be about 0.3, and the estimated resistance for the smaller heatsink is 0.35. This would suggest that reducing the length of the heatsink increases the thermal resistance, and that would be a very interesting path to study in the future. So this is the new findings that I had this week, and I will continue documenting everything in the future, any other result that I get in the future.